Today we are graphing logarithms. So we'll graph the most basic ones first, and then we'll do the same thing that we did with the exponential functions. We'll graph those translations, those transformations. We'll move them around the xy plane. And I think all of our graphing will just be translations, no transformations. Okay? So let's just, oh, well, that's weird. Get rid of all those stupid little dots. Okay, so let's graph y equals log base 3 of x. All right, so you can't graph this on your graphing calculator. Your graphing calculator doesn't do log base 3. It only just does log base 10 and log base e, which you'll get to next year in pre-calc. So in order to graph these, I'm not going to graph a logarithmic function per se. I'm going to change it into an exponential function because I understand exponents. I know what to do with these. So change this y equals log base 3 to x to an exponential. So I have 3 to the y equals x. All right, so that's something I know I can calculate. So I'm going to make myself a little xy table. But my x is the isolated variable. So I'm not going to put in numbers for x. It'll be too hard to work backwards. But if I instead put in numbers for y, then I can take 3 to that number and solve for the x. So I'll use my standard numbers, -2, -1, 0, 1, 2, for my y's. And then I'll calculate the x's. Well, 3 to the -2, you could get that in your calculator if you wanted to. It's 1 over 3 squared, it's 1/9. 3 to the -1 is 1 over 3 to the first power, or 1/3. Now the ones that you should know without thinking about it. 3 to the 0 is 1. 3 to the first is 3. 3 to the second is 9. Okay, so there's my xy chart. Now I can graph it. My y's are going from -2 to 2. That's easy. My x's are going from, very close to 0 up to 9. So I think I'll go by 2's. 2, 4, 6, 8, 10. Okay, now I'll graph my dots. From the origin, I go over 1/9, go over very little, and go down 2. Put a dot. For the next point, I go over 1/3, still pretty small, and down 1. For the next one, I go over 1 and put that on the x-axis. Then I go over 3 and up 1, and over 9 and up 2, and there's my last dot, and there's my log base 3 of x function graphed. This one is the inverse of y equals 3 to the x. And so you could graph this by doing this as a reflection, over the y equals x line of y equals 3 to the x. Or I think this way is easier and you've got a little less to do here. So we want to define some things on this graph, and we're a little lax with exponentials. We'll make sure we go back and define some things. We want to talk about domain. we want to talk about range, and then we're going to talk about something called an asymptote. All right, so my domain are going to be my x values. So it looks like for my x-axis, I'm not having any values that are over to the left of the y-axis. I'm not having any negative values. Looks like my x's are all positive values. ASYMP, that's supposed to be an M, sorry, TOTE. ASYMP, TOTE. So my domain is going to just be positive numbers. As we found it in the homework problem, you don't have negative numbers for your answers for when you take a number to an exponent. My range, boy, I've got negative and positive numbers in my range. So I'll call that all real numbers. The asymptote is a line that the graph gets closer and closer and closer to, but never gets to. So this line, as it's going, this curve as it's going out towards the left, is getting higher and higher and higher, just very, very slowly. But as I'm going towards the y-axis, I notice this curve is getting just closer and closer to the y-axis, but I don't think it's ever going to get there, and it's never going to cross over. Yes, sir? So I'm seeing with my, mostly by, the domain and range aren't all real numbers. The domain is greater than 0 because remember in the problem number 20 from last night, we weren't able to get a negative number for the argument for our log. So it's always going to be greater than 0 unless we do some kind of a shift. Okay, you'll see that next. In my range, I've got positive and negative numbers and 0, so looks like there's I'm going to be able to get any kind of number, any kind of real number out of this. All right, so this asymptote, I'm getting closer and closer to the y-axis. The equation of the y-axis is x equals 0. So I'm going to call my asymptote x equals 0. All right. Pardon me? The equation of the y-axis is x equals 0, so I call my asymptote x equals 0. I'm getting, on the left side of my graph here, it's going down quickly, it's falling straight down, and it actually is getting closer and closer and closer to the y-axis, but it never gets there, never crosses over. I go 1/3, then 1/9, then 1/27th, but I never get negative there. Okay. Why is the asymptote x equals 0? Because my x's are going to get closer and closer to 0, but they're never going to get there. So what number could I take? Could I take 3 to some power? What number? Yeah, I got 3 to the y equals x. What number could I take 3 to? What power could I take 3 to and get 0? For the logarithms, the asymptote is going to be x equals 0. Unless we have a shift, and I will show you a shift here in just a second. A translation, left-right shift. Then I'll show you how it changes. It's going to change with the h. Yes, next question. Yes. Yeah. Keep that asymptote as x equals 0 for the basic log functions, and you'll be in good shape. Okay. And on the asymptotes are what? Yeah. Because 3